Good day, Ninja Pikin. Welcome to our channel. Do not forget to like and hit the subscribe button, and also make comments below on how we can improve our video. So on the last session, we were talking about glycolysis and how glucose comes into the cell and undergo different modification to become pyruvate. And these are different tissues and organs in which glucose is being sent to them for metabolical activities. And I spoke about the glut transporters that allows the intake of glucose into the cell. So these are different organs and different types of glut transporters which are attached to them. GLUT1 transporters, you have blood filters and the blood-brain barrier to GLUT4 transporters. Well, the reason why I named them was because of these GLUT4 transporters. GLUT1, 2, and 3 are independent of insulin. It means they do not need the presence of insulin before they can carry out their activity. They can allow the entrance of glucose inside and outside of the cell without the involvement of the presence of insulin, because insulin is being produced by the pancreas from the beta cells of the islet of Langerhans to regulate high blood sugar, otherwise known as hyperglycemia. But in the case of GLUT4, GLUT4 is dependent of insulin. It means there needs to be the presence of insulin before it can allow the entrance of glucose in and out of the cell. So this 6 carbon molecule, which I represented as glucose here, comes into the cell through this glut transporter because it's bidirectional. It can go in and come out. So when glucose comes into the cell, when it comes into the cell, we would not want glucose to go out of the cell. So what do? We add a phosphate group. Now you might ask, how did we get this phosphate? So there are regulatory enzymes that allow the entrance, that allows this glucose to become glucose 6-phosphate, The enzymes are hexokinase and glucokinase. So hexokinase, there's a difference between these two. Hexokinase are found in muscles and other tissues, while primarily glucokinase is found only in the liver. So for glucose to become glucose 6-phosphate so that it can go back outside, it can go through the glut transporter outside the cell, you need this enzyme to add phosphate. Because what is the function of a kinase? A kinase is an enzyme that phosphorylates. It drops phosphate to its substrate. So when it adds phosphate to glucose, it becomes glucose 6-phosphate to the 6 carbon, 1, 2, 3, 4, 5, 6, glucose 6-phosphate through the enzymatic activities of this enzyme. So this is hexokinase type 2. Another name for glucokinase is hexokinase type 4. So these are the two enzymes that regulate this particular reaction. And where did it get the phosphate from? That means it got it from ATP. So ATP is being used to give us ADP plus PI. ATP stands for adenosine triphosphate, while ADP is adenosine diphosphate plus phosphate. So this phosphate is now brought to this glucose by the action of hexokinase or glucokinase, depending on the tissue. I told you hexokinase is for muscles and other tissue, while glucokinase primarily is found in the liver. So this is glucose 6-phosphate. So from glucose 6-phosphate, it's now, this is glucose 6-phosphate. From glucose 6-phosphate, there is an enzyme that changes glucose 6-phosphate to fructose 6-phosphate. Fructose 6-phosphate. So the action on glucose 6-phosphate is just a change, an isomerization reaction where the glucose 6-phosphate, glucose is an aldehyde, while fructose is a ketone. So the enzyme that is responsible is just isomerizing glucose to become fructose by changing the carbonyl group from an aldehyde to a ketone. So the enzyme responsible for this reaction is called phosphohexose kinase. Phosphohexose kinase is responsible to change glucose 6-phosphate, phosphohexose isomerase, mind you, because it's isomerizing, sorry. Phosphoglucose isomerase isomerizes this reaction by changing glucose 6-phosphate to fructose 6-phosphate. This is fructose 6-phosphate. From glucose 6-phosphate to fructose 6-phosphate. So now this next step is very, very important. This next step is very important because it has a lot of regulatory activities. So from fructose 6-phosphate, there is an enzyme that is responsible for changing fructose 6-phosphate to fructose 1,6-bisphosphate. Do not forget, we have a 6 because we already have fructose 6-phosphate. We have a phosphate group here, and we also have another phosphate group. So the enzyme responsible for this reaction is called phosphofructose 1. Phosphofructose 1, but I rather write it this way. Phosphofructose kinase 1. So this enzyme is responsible for modifying fructose 6-phosphate to fructose 1,6-bisphosphate. And you might ask, what is the difference between bisphosphate and biphosphate? The difference between bisphosphate and biphosphate is this. In the case of bisphosphate, the carbon atoms, or the carbon that is between this phosphate and this phosphate, you have 2 to 3 different carbons between the first phosphate and the last phosphate. That is why you call it bis. But when the phosphate are closer together, maybe 2, 3, that's when you call it biphosphate, because there is no carbon atom that is between, that is separating the first phosphate to the second phosphate. But when they are close together, you call it biphosphate. But when they are apart by the number of carbon between them, you call it bisphosphate. So this molecule we have here is fructose 1,6-bisphosphate, which is regulated by the enzyme called phosphofructose kinase 1. So the question you should ask now is where we got, because we only had one phosphate here. So where did we get this second phosphate? So that means ATP was also used. So in this reaction from fructose 6-phosphate to fructose 1,6-bisphosphate, ATP was also utilized to give me ADP plus PI. So phosphofructose kinase 1 carries this phosphate and phosphorylates fructose 6-phosphate, giving us fructose 1,6-bisphosphate. So this molecule here is called, so I'll just bring it here. This molecule is called, well, let me put it here so you can see it clearly. This molecule is called fructose 1,6-bisphosphate. So now we're going to the next molecule here. So from fructose 1,6-bisphosphate, it's now differentiated into 2 different molecules. The first molecule here is called dihydroxyacetone phosphate. While this is called glyceraldehyde 3-phosphate. Glyceraldehyde 3-phosphate. Glyceraldehyde 3-phosphate. Glyceraldehyde 3-phosphate. So this is the first phosphate, which is called, this is the first molecule. So I said, for fructose 1,6-bisphosphate to actually differentiate or divide into 2 different molecules, there is an enzyme that does this. So there is an enzyme that does this. It converts fructose 1,6-bisphosphate into 3 carbon molecules, 3 carbon molecules. The first molecule it converts fructose 1,6-bisphosphate to is dihydroxyacetone phosphate. And glyceraldehyde 3-phosphate. Glyceraldehyde 3-phosphate. So there is an enzyme that actually converts fructose 1,6-bisphosphate to dihydroxyacetone phosphate and glyceraldehyde 3-phosphate. The enzyme that does this reaction is called aldolase. So this is the enzyme that is responsible for breaking down fructose 1,6-bisphosphate to dihydroxyacetone phosphate and glyceraldehyde 3-phosphate. So most of the dihydroxyacetone phosphate is being converted to glyceraldehyde phosphate depending on the body's demand. So that's why you have this bidirectional arrow. It shows that this is being converted to this. So how many of these would you have? 2. So whatever reaction that goes on here, you have 2 reactions. In glycolytic reaction, you have 2 phases. The first phase before fructose 1,6-bisphosphate is converted to dihydroxyacetone phosphate and glyceraldehyde 3-phosphate is called the preparatory phase. You are preparing it. Preparatory phase. So after glucose is being eventually divided or degraded to become pyruvate, the end product is called pyruvate. That phase is called the payoff phase. Don't forget, the first phase is called the preparatory phase, while the second phase is called the payoff phase. I just decided to tell you that, but it's not that necessary, but I think you should know. So we have glyceraldehyde 3-phosphate and dihydroxyacetone phosphate. So but there is an enzyme that is responsible for actually shunting this dihydroxyacetone phosphate to become glyceraldehyde 3-phosphate. What is that enzyme called? It's very important we know that. The enzyme is called triose phosphoisomerase, because dihydroxyacetone phosphate is a ketone and glyceraldehyde 3-phosphate is an aldehyde. So the conversion of dihydroxyacetone phosphate to glyceraldehyde 3-phosphate is being done by this particular enzyme called triose phosphoisomerase. So this I'm just going to denote it as glyceraldehyde 3-phosphate, while this will be denoted as hydroxyacetone phosphate, DAHP. So triose phosphoisomerase is the enzyme that is responsible for shunting or changing dihydroxyacetone phosphate to glyceraldehyde 3-phosphate. Now we're beginning to start, or we are about to start, the payoff phase. So you have to pay attention because this is very, very important. We need to understand this step. This is very, very important. So now we have, there's a phosphate group here, mind you, there's a phosphate group, and we have, we'll have a phosphate group here too. Glyceraldehyde 3-phosphate. So glyceraldehyde 3-phosphate is now converted to 1,3-bisphosphoglycerate. But before this happens, there is an introduction of NAD positive. So What does NAD positive does? NAD positive have the ability of removing hydrides. It removes hydride from glyceraldehyde 3-phosphate. And when it does that, it has the ability of adding a phosphate to this particular reaction. So a phosphate is being added to this particular reaction. What is an hydride? We know this is a hydrogen having a proton and 1 electron. But a hydride has 2 electrons. So what is the definition of a hydride? A hydride is just a hydrogen atom plus 2 electrons. So by so doing, NAD plus has the ability of yanking off the hydride from the glyceraldehyde 3-phosphate, and it now becomes NADH. It becomes NADH. So by so doing, it can just add a phosphate by this reaction. So what is the enzyme that is responsible for actually adding these phosphates to this particular group? Because you have glyceraldehyde 3-phosphate and NAD positive. What is the enzyme that is responsible for initiating this reaction? It is called glyceraldehyde 3-phosphate isomerase. Glyceraldehyde 3-phosphate dehydrogenase, mind you, please. Glyceraldehyde 3-phosphate dehydrogenase. Glyceraldehyde 3-phosphate dehydrogenase. Glyceraldehyde 3-phosphate dehydrogenase. That is the name of the enzyme that is responsible of catalyzing this particular reaction. So it brings in NAD positive. While NAD positive picks up the hydride, it actually takes off the hydride from this particular reaction and becomes NADH by adding phosphate to this particular substrate. And this becomes from glyceraldehyde 3-phosphate. Do not forget you had a phosphate group on the third carbon. And because of adding a phosphate to this particular substrate, you have another phosphate. This particular molecule is called 1,3 because you have 1 phosphate on the first carbon and you have another phosphate on the third carbon. So it is called 1,3-bis. Why is it called bis? Don't forget I told you bis. The reason why it's called bis is because there is a carbon. There's a carbon molecule between the phosphates. That's why it's bis. If they are closer together, it's called bi. 1,3-bisphosphoglycerate. Bisphosphoglycerate. That is the name of the enzyme. So let's continue. I hope we're together. So from glyceraldehyde 3-phosphate, you have 1,3-bisphosphoglycerate by this particular enzyme called glyceraldehyde 3-phosphate, turning NAD positive to NADH by also adding phosphate to this group to give you 1,3-bisphosphoglycerate by this enzymatic reaction. So from this, what next? So from 1,3-bisphosphoglycerate, do not forget we have a phosphate group here. There's a phosphate group here. So this particular molecule is called 3-phosphoglycerate. 3-phosphoglycerate. What is the enzyme that is responsible for this? Here we had 1,3-bisphosphoglycerate, and here we have 3-phosphoglycerate. That means we've lost a phosphate. Where did it go? So the enzyme that is responsible for this is called phosphoglycerate kinase. That is the name of the enzyme that catalyzes this reaction from changing 1,3-bisphosphoglycerate to 3-phosphoglycerate. Where did it get it from? That means ATP is formed in this reaction. By so doing, it brings up ADP plus the phosphate it takes off, because kinase is, I told you, a kinase phosphorylates a substrate. So you have ADP plus PI to give you ATP. So do not forget, I told you this reaction occurs twice because we shunted DAHP to become glyceraldehyde. So we have two reactions occurring here. So how many ATP we would have here? We have 2 ATP. How many NADHs we have here? We have 2 NADH. Because glyceraldehyde, I told you this is becoming glyceraldehyde. How many glyceraldehyde phosphate, 3-phosphate do you have here? You have 2. Because this is also converted to glyceraldehyde 3-phosphate. So if you have one glyceraldehyde 3-phosphate undergoing this reaction, you also have another undergoing this reaction. So we cannot just write the 2 together. So you just know that you have 2 NADH, you have 2 ATP formed from this reaction. So from 3-phosphoglycerate, so it becomes 3-phosphoglycerate. From 3-phosphoglycerate, so this is where your phosphate group is. So we just switched the position of the phosphate group. The phosphate group was on the 3rd carbon, but in this substrate, you have the phosphate group on the 2nd carbon. So what enzyme is responsible for changing? It is a change. What enzyme is responsible for changing 3-phosphoglycerate to 2-phosphoglycerate? Thank you. 3-phosphoglycerate to 2-phosphoglycerate. The enzyme responsible for this, for the conversion of 3-phosphoglycerate to 2-phosphoglycerate, is called phosphoglycerate mutase. This is the name of the enzyme that is responsible for changing 3-phosphoglycerate to 2-phosphoglycerate. So our next substrate is called phosphoenol pyruvate. Phosphoenol pyruvate. Okay, so I'm going to just give you a little illustration of what an enol is.